Hi, today is day 15. It is Monday and we are going to be talking about square root functions. So here are my notes so that you guys can see everything. If you want to freeze the camera and then write that stuff down, and then I'll go straight into it. Okay, so I'm going to look at this top part right here, and if you look up here, it shows you what a square root function looks like. Obviously, square root. And that also can be written as x to the 1/2 power because those are the same thing. Remember, we had practiced if you have an exponent here and the number here, how they go over each other. So what I want to talk to you about is what the graph of this looks like. And as much as I hate graphing, we're going to have to do it for this one. So we're going to figure out if this is the function right here, and we can just zone in on this part. What are the values that I can put in for x? Well, I can't make x a negative number because I can't square root a negative number. So the smallest number that I can put in here, and this is the parent function, is a 0. And then to make my life easy, I'm going to use perfect squares since I'm having to square root them. So I'm going to go from 0 to 4, or to 1. I can do 1. To 4, and then to 9. Okay, and as I put this in, I plug in 0 here. The square root of 0 is 0. Plug in 1. The square root of 1 is 1. The square root of 4 is 2, and the square root of 9 is 3. So then I'm going to take my graph paper and I'm going to draw a little sketch of what that's going to look like, because this isn't a quadratic function anymore. So I'm going to give myself a little bit of leeway here. Oh, my pencil's getting stuck. All right, and we're going to plot these points. 0, 0, 1, 1. Whoops, you can hardly see what I'm doing. 4, 1, 2, 3, 4, 2. And 9, 3, 4. 5, 6, 7, 8, 9, 1, 2, 3. So this function looks something like that. And I can't go over here, so the arrow would not continue on this side. With quadratics it did, with square root functions it does not. So it's going to keep going, but it is going to keep going over here because I could keep plugging in other numbers. All right, so what we're going to do is we're going to answer these questions based on that picture. And I'm going to keep this picture right here so we could take a look. So what is the x-intercept? The x-intercept is 0 because that's where it goes through the x. The y-intercept is also 0 because that's where it goes through the y. The domain. So the domain is not all real numbers because it doesn't keep going on this side. But it is all real numbers greater than 0, because if I look at the x-axis at the 0, it's going to be on the right side of it. So I'm just going to put x is greater than or equal to 0. The range is up and down, so it doesn't go down here. So I'm going to say that the range is y is greater than or equal to 0 because it's above the 0 line on the y. All right, so when I'm looking at other square root functions, what I want to do is just have this picture in my mind or on my paper, and I'm going to just basically keep going back to this to see what happens in my other functions. I'll show you what I mean. So down here, this part down here just says, you know, what transformation is taking place, and the transformations are just like what we had done before, except for instead of being whatever functions we were doing, now they are square root functions. And then we're going to also tell what translation happened, the x-intercept, the y-intercept, and the domain and range. So I'm going to put this picture that we just graphed. This was the parent function. Now, remember, what does this mean right here? This just tells you that it reflects. So I know that it's going to be the same exact picture, except for my new function is going to be a reflection right down here somewhere. Okay, so what translation, what transformation, because translation is when it slides left, right, up, down. Transformation would be a reflection. So we're going to say that it reflected. All right, what is the x-intercept? Well, this is the same place. This hasn't moved. So my x-intercept is 0. My y-intercept is 0. My domain. Well, my domain still goes on forever over there. So my domain is x is greater than or equal to 0. Now my range is a little different because before my range was above the 0 line, and now my range is beneath the 0 line. So my range is y is less than or equal to 0 because it goes down. Now I'm going to erase that function that I just drew because I always like to go back to my parent function, because then I don't have to actually do my X and Y chart and graph it. And you could if you wanted to, but we know our translations, so it's easier to just go to that. So remember, what does this mean if this is a -2 that's outside of the radical? Well, it just means that this is going to be shifted down 2. So I know it's going to look something like that. All right, because it just gets shifted down 2. So what translation took place? It went down 2. What's my x-intercept? Well, I mean, I just looked here and said, okay, each point is being shifted down 2. Since that was a pretty point, I know that it got shifted down 2 here. So my x-intercept is 4. My y-intercept is going to be -2. My domain is still all real numbers. The x is greater than or equal to 0 because it's on the 0. And then my range is going to be x is greater than or equal or -2 because it's -2 on the y, sorry. The y is -2, the x is still 0, so that's why those numbers are still there. Okay, so to do the next one, once again, I just like to go back to my parent function instead of having to regraph this again. So I'm going to erase that, and I'm going to say, well, what does this do to my parent function? This shifts it up 3. All right, 1, 2, 3. So my picture is going to look something like that. Once again, what happened? It went up 3. My x-intercept, oh, well, look, this is not even going to go through the x at all. So there is no x-intercept. My y-intercept is 3 because it just shifted up 3. Whoops, it's a y. My domain is x is greater than or equal to 0 because it's on this side. And my range is y is greater than or equal to 3 because it's above the 3 line. Okay. So I'm giving you lots of examples, and I'd like you guys to go ahead and try to do these two without me. Okay, now hopefully you've frozen the camera, you've tried it by yourself, and let's see what this means. So when we have x minus 3, remember this moves it to the right. When it's underneath the radical, it's kind of opposite to what you think. So if this is my parent function, I move it right to the 3. So once again, it's going to look something like that. And so you can see here that what happened, it moved right 3. My x-intercept is 3. X-intercept is 3. My y-intercept, it's not going to go through the y at all. So I don't have a y-intercept. My domain is x is greater than or equal to 3 because on the x-axis, it is on the right side of the 3. And then the range, it's above 0. Right? My last example here, once again, I'm going to erase this. And this, what transformation happens? It went up 2. My x-intercept, and I like to just draw that little sketch. What happened? 1, 2, goes up like this somewhere. My x-intercept is going to be 2. My y-intercept is none because it does not go. Oh, I'm sorry, I said that backwards. The x-intercept, my goodness. Okay, the y-intercept is 2. The x-intercept is none because it's not going to go through the x. My domain, x is greater than or equal to 0. And my range, y is greater than or equal to 2 because it goes above the 2 on the y. All right, the next part that I want to show you, so using those transformations on those, really helpful. Okay, the next part that I want to show you is, I'm going to just come out so you can see it. Those are all of the rest of my notes. Okay, for each function, f of x equals the radical x. How does the average rate of change from x equals 0 to x equals 0.3 compare to the average rate of change for x equals 0.3 to x equals 0.6? So I'm going to zoom back into my table, And this isn't that bad because I'm only having to plug in certain numbers, and I'm plugging in the numbers that they told me. And so they want me to find the rate of change here. You know, what's the rate of change, the average rate of change between these points and the average rate of change between those points, and compare them. That's all they're asking. Okay, so I'm gonna start off, grab your calculator, and you're gonna take 0 and you're plugging it into x. So the square root of 0 is 0. And then I have to find the square root of 0.3, 0.54. I'm sorry, let me put 0.55 because of rounding. And I'm gonna go ahead and put 0.6, square root is 0.77. Okay, so now I just plugged in my numbers. To find the average rate of change, what I have to do is, remember we did this with linear functions where we found the change in x and the change in y, and then it was the change of y over the change in x. It's just not gonna be the same every time like a linear function. So we're gonna find the rate of change here, which is 0.55. The rate of change here is 0.3. And then we're going to take this number, the y, and divide it by the x. 1.1. Now this is where rounding can get a little tricky. You can be a tiny bit off if you rounded, you know, someone rounded to the 10th place, someone else rounded to the 100th place, but that's probably close enough. Okay, so let's find the rate of change there. 0.22, and then this is also 0.3. Whoops, I just realized that I put the wrong number back there. This is supposed to be 0.3. Sorry about that. My fault. Okay, so 0.55 divided by 0.3, 1.8, 1.833. Okay, this part should be right. 0.22 divided by 0.3 gets me 0.73. I'm just going to double check that because I'm feeling like I have stuff in the wrong place. 1.8, 0.7, I'm sorry. Okay, so now this is the average. So this is the average rate of change for the first part, and this is the average rate of the change for the second part. So when it says compare them, we can then subtract them and say, you know, the difference is 1.07. So when I compare them, there's a larger rate of change between the first part. And if we go back and think of our graphs, this should kind of make sense. At the beginning of our graph, there was a lot more rate of change than there was towards the end of it. You know what I mean? Even though those aren't the exact numbers, as we are closer here, the rate of change was larger. So it's not like a linear function where you should get the same answers every time, okay? So here's another way that that problem could be worded. They give us an equation, h of x equals radical 2x. Find the average rate of change over the intervals. And they tell us we're gonna look for 8, 10, and 12. Okay? However, when we look here, this part is basically saying, what's the rate of change going from 8 to 10? So we're gonna solve that. And then here's the second problem. What's the rate of change when we go from 10 to 12? Okay, so I could make my chart 8, 10, 12, just because it's gonna make it a little bit easier. When I plug this in, I'm gonna say 2 times 8 and square root it. Well, 4, we should have known that one. 2 times 10 square rooted, 4.47. Whoops. And then let's do 12. 4.9. Okay, so the first question is asking what's the rate of change just for this first part. So we have 0.47, sorry. The rate of change there, the rate of change is 2. So when I divide the change in y over the change in x, my rate of change for this first part is 0.235. Okay, if find the rate of change here and the rate of change here. And this is 0.43, and then 0.43 divided by 2 gets me 0.215, which once again, you can see that this rate of change is a little bit smaller than this rate of change, which should make sense to us, okay? That's it for today. You have, you're gonna have notes tomorrow, and today you're just gonna take a picture of your notes and send them to me.